Scene opens with a slow-motion shot of a sunrise over a vast, still ocean. The light glints off the water, creating a dazzling display of color. The music is ethereal and atmospheric, a blend of strings and soft synth pads. A series of rapid, almost subliminal images flashes across the screen. A close-up of a human eye dilating a time-lapse of a flower blooming towards the light, an ancient sundial, a solar panel array in the desert, a child laughing and running through a field, a fiery solar flare erupting from the sun's surface. The images are visually dense and layered. The music swells slightly as the title card appears. The sun. The images continue to flicker in the background. The scene shifts to a narrator, seen only in silhouette, standing against a backdrop of swirling, abstract cosmic visuals. The narration begins in a calm, measured, almost hypnotic tone. The sun. It is the first thing we see, the last thing we see. It is the silent, unwavering metronome to which all of life dances. We wake with it, we work under its gaze, and we measure our existence by its relentless journey across the sky. It is the most familiar object in our lives, so familiar that we barely notice it. But to truly see it, to understand what it is to look into the heart of creation, into a furnace of unimaginable power and a story billions of years in the making. What is this colossal sphere of fire that hangs in our sky? How does it pour forth the light and heat that sustains a world? And why, in the grand, cold emptiness of space, does it burn at all? The answers lie not just in physics and astronomy, but deep within the fabric of our own psychology. In the way our minds have evolved to perceive the ultimate source of all our energy in all our days. To begin, we must travel to its core, a place of such extreme conditions that our language and imagination falter. Here, the pressure is over 250 billion times that of Earth's atmosphere. The temperature is a staggering 15 million degrees Celsius. In this crucible, the very atoms of existence are ripped apart into a superheated plasma of protons and electrons. This is where the sun's magic, its alchemy, takes place. It is a process known as nuclear fusion. Under this immense gravitational pressure, hydrogen nuclei, simple protons, are forced together with such violence that they overcome their natural repulsion. They collide, they merge, they transform. For hydrogen protons are crushed into a single helium nucleus, but here is the miracle. The resulting helium nucleus is slightly less massive than the 4 original protons combined. That missing mass, a tiny fraction, doesn't simply vanish. It is converted into a pure, explosive burst of energy, as described by Einstein's famous equation, E equals mc, every single second. The sun converts about 600 million tons of hydrogen into helium. In doing so, it annihilates 4 million tons of matter, releasing an amount of energy equivalent to trillions of nuclear bombs detonating every single second. This is the engine of the sun. It is not a fire in any sense we understand it. It is not burning wood or coal. It is a sustained, controlled, gargantuan nuclear reaction, a star forging heavier elements from lighter ones, and in the process, bathing its solar system in the byproduct of its creation, pure energy. But this energy does not reach us immediately. A photon, a single particle of light, born in the inferno of the sun's core, begins an arduous journey. It does not travel in a straight line. Instead, it is absorbed and re-emitted countless times by the dense plasma of the radiative zone, the layer surrounding the core. It zigzags, ricochets, and stumbles its way outward in a chaotic random walk. A journey that would take light just over 2 seconds in a vacuum can take this photon, on average, over 100,000 years to escape the sun's interior. Imagine that. The light that warms your face on a summer afternoon may have begun its life in the sun's core before human civilization even existed, before the last ice age had ended. After its long trek through the radiative zone, the energy reaches the convective zone. Here, the process changes. The plasma is cooler and more opaque. Energy is no longer primarily transported by photons but by the churning, boiling motion of the gas itself, much like a pot of water on a stove. Hot plumes of plasma rise to the surface, release their heat and light into space, then cool and sink back down to be reheated. This constant, violent boiling is what gives the sun's surface, the photosphere, its grainy, textured appearance. It is a sea of roiling convection cells, each the size of a country on Earth, living and dying in a matter of minutes. This is the visible surface we see, the edge of the sun, from which the light finally streams unimpeded into the void. So, we have a how, a mechanism of fusion and energy transport. But this only deepens the mystery of why. Why did this process begin? Why does the sun exist in this form, in this place, at this time? The answer is gravity. The story of the sun begins some 4.6 billion years ago, not as a star, but as a vast, cold, diffuse cloud of gas and dust, a molecular nebula drifting through the Milky Way. This cloud was a remnant of previous generations of stars, enriched with the heavier elements they had forged and scattered in their explosive deaths. Something disturbed this quiet cloud, perhaps the shockwave from a nearby supernova causing it to begin to collapse under its own gravity. As the cloud contracted, it began to spin, flattening into a rotating disk, the protoplanetary disk. At the center of this spinning disk, the vast majority of the matter, over 99.8% of it, accumulated. As more and more gas and dust fell inward, the pressure and temperature at the center began to rise precipitously. The protostar at the core grew hotter and denser over millions of years. It was a gravitational feedback loop. More mass created stronger gravity, which pulled in more mass, which increased the pressure and temperature, which in turn fought against the gravitational collapse. For a long time, gravity was winning, but eventually, a critical threshold was reached. The core became so hot and so dense that the conditions were finally right for nuclear fusion to ignite. The outward push of the energy released by fusion suddenly became powerful enough to counteract the inward pull of gravity. A state of equilibrium was reached, a delicate balance between collapse and explosion. At that moment, a protostar was born as a true star. Our sun shines not because it wants to, but because it must. It is the inevitable outcome of the laws of physics, a constant, cosmic balancing act between the relentless crush of gravity and the explosive power of nuclear fusion. This understanding of the sun's mechanics profoundly reshapes our psychological relationship with it. It is no longer just a benevolent lamp in the sky. It is a monster of incomprehensible scale, a seething nuclear furnace held in check by its own immense mass. The light it provides is not a gentle gift, but the radiation from a continuous thermonuclear explosion. This duality is fundamental to our experience. The sun is both creator and destroyer. Its energy drives photosynthesis, fuels our climate, and makes life possible. Without it, the Earth would be a frozen, lifeless rock. Yet, this same energy, in the form of ultraviolet radiation, can damage our DNA, cause cancer, and burn our skin. The solar wind, a constant stream of charged particles flowing from the sun, would strip away our atmosphere if not for Earth's magnetic field. Solar flares and coronal mass ejections, sudden, violent releases of energy, can disrupt our power grids, disable satellites, and pose a threat to astronauts. We live in a constant, delicate negotiation with a star that both nurtures and threatens us. This is the paradox of the sun. Our existence is entirely dependent on a process so violent it would vaporize us in an instant if we were to get too close. Our psychology has evolved in this bubble of safety, the Goldilocks zone, where the sun's power is tamed by distance into something life-giving. We are psychologically wired to seek its light, to feel its warmth as comfort and safety, because our very biology is a product of its energy. Our circadian rhythms, our moods, our production of vitamin D are tethered to the sun's cycle. Ancient cultures instinctively understood this power, deifying the sun as Ra, Helios, or Apollo. They recognized it as the ultimate source of life, power, and order. Modern science has simply given us the technical language to describe the same profound truth. We are children of the sun, made from the dust of long-dead stars, and animated by the light of our own. The visuals shift back to slow motion, beautiful shots of nature, a bee collecting pollen from a sunflower, sunlight filtering through the canopy of a dense forest, waves crashing on a sun-drenched beach, a panoramic view of a city skyline at sunset. The music becomes more reflective and poignant, with a simple piano melody taking the lead. So, when you next feel the warmth of the sun on your skin, pause for a moment. Remember the journey that light has taken. It began, perhaps 100,000 years ago, as a gamma ray in a 15 million degree core, the product of atoms being forged in a gravitational vice. It fought its way through a dense sea of plasma, was carried to the surface on a boiling plume of gas, and then traveled 93 million miles across the vacuum of space in just over 8 minutes to end its journey on your face. You are feeling the echo of a nuclear reaction, the ghost of matter converted into pure energy. You are experiencing the endpoint of a causal chain that began with a collapsing nebula 4.6 billion years ago. The sun works because of the delicate, violent balance between gravity and fusion. It exists because of the inexorable laws that govern the cosmos. And in its light, we find not just warmth and illumination, but a profound connection to the universe itself. We are, in the most literal sense, bathed in the history of the stars. The final shot is a time-lapse of the sun setting, the sky turning from orange to deep purple. The screen fades to black as the last sliver of light disappears below the horizon. The music fades out, leaving a moment of complete silence.